So this is chapter 15, section 2. That would be from pages 379 to 382. The subject is stream erosion, and the objectives are to summarize how a river develops, to describe the parts of a river system, to explain the factors that affect the erosive ability of a river, and to describe how erosive factors affect the evolution of a river channel. So let's talk about the parts of a river system for a moment. First, you've got tributaries. These would be streams that flow into a lake or into a larger stream. Basically, they feed it. The watershed is the area of land that is drained by a river system. You've got a large flat area, rain falls on it, puts water into the ground. All that water drains out to the ocean, but they do so by collecting into a stream through tributaries. That large flat area that has all that groundwater that drains out through the river is called the watershed. Now, a river system is made up of a main stream and tributaries, and the ridges or elevated regions that separate watersheds are called divides. The relatively narrow depression that a stream follows as it flows downhill, it's called its channel. That's like the actual little dip the river seems to flow through. The edges of a stream channel that are above water level are called the stream's banks. So it's the edge of the channel, right? And, you know, river bank is the edge of the river. It's the part that's above the water level that's at the edge of the channel. So the part of the stream channel that is below the water level is called the stream's bed, right? So you've got bed, banks, and that whole depression is called the channel. So the stream channel gradually becomes wider and deeper as it erodes its banks and bed. River systems change continuously because of erosion. In the process of what's called headward erosion, channels lengthen and branch out at their upper ends where the runoff enters the streams. The process known as stream piracy is where a stream from one watershed is captured by a stream from another watershed that has a higher rate of erosion. The captured stream then drains into the river system that has done the capturing. Stream load refers to the materials other than the water that are carried by the stream. A stream transports soil, loose rock fragments, and dissolved minerals as it flows downhill. Stream load can take three forms: suspended load, bed load, and dissolved load. So as the river is eroding its banks and its bed, of course, that's made of soil, it's made of rock, so it's going to be knocking up pieces of sediment, whether they're large like gravel and sand or they're smaller like silt and clay. That stuff is going to get carried along by the water. That's called the stream load. The stream load is partly made of the suspended load that consists of particles of fine sand and silt, so smaller stuff. The velocity or rate of downstream travel of the water keeps those particles suspended so they don't sink to the stream bed. Water's moving fast enough to keep sand and silt from settling out. But the bed load is made up of larger, coarser materials such as coarse sand, gravel, and pebbles. This material moves by sliding and jumping along the bed. The dissolved load is mineral matter transported in liquid solution. So from large, relatively speaking, gravel, pebbles, things that are too heavy to be picked up by the water are just kind of scooted along the bottom by the water. Medium/smaller sized things that are able to be carried along by the water will be carried along by the water as suspended load. And things that are like molecular or atomic in size that are just dissolved, that's called the dissolved load. Stream discharge refers to the volume of water that flows within a given time. The faster a stream flows, the higher its discharge, and the greater the load that the stream can carry. A stream's velocity also affects how the stream cuts down and widens its channel. Swift streams erode their channels more quickly than slow-moving streams do. A stream gradient is the change in elevation over a given distance. So near the headwaters, or the beginning of a stream, the gradient generally is steep. The area of the stream has a high velocity, which causes rapid channel erosion. As the stream nears its mouth, where the stream enters a larger body of water, the gradient often becomes flatter. So here's a picture of three different gradients. First, you see a steep gradient near the headwaters. Around the mouth of the river where it actually like enters a lake or the ocean, you've got a lower gradient, and that water is not moving very quickly. That would be more of a gentle stream or kind of like a lazy river. And channel erosion is illustrated in the other picture. These pictures are all in your textbook as well. Okay, so the evolution of river channels, how river channels change over time. So meandering channels refers to a channel with meanders in it, and a meander is one of the bends, twists, or curves in a low gradient stream or river. Remember, low gradient means not very steep. When a river rounds a bend, the velocity of the water on the outside of the curve increases. However, on the inside of the curve, the velocity of the water decreases. The decrease in velocity leads to the formation of a bar of deposited sediment such as sand or gravel. Remember, water needs to be moving faster to keep a suspended or bed load. So when water is speeding up around a curve but slowing down around the inside, that slower moving water isn't able to keep as much sand and silt suspended anymore, and so it ends up being deposited in what's called a bar. So as this process continues, the curve enlarges while further sediment deposition takes place on the opposite bank where the water is moving more slowly. So meanders can become so curved that they almost form a loop separated by only a narrow neck of land. So think about this. On the inside where it's slow, you got a bar forming. On the outside where it's fast, you've got erosion happening at a higher rate. So basically the bend becomes more extreme because what's happening on the outside of the bend is eating away at the bank, and what's happening on the inside of the bend is adding to the bank. You get this really tight loop. And when the river cuts across the neck, the meander can become isolated from the river, and you get what's called an oxbow lake, just a curve of a river that has been cut off from the original stream, and now it's just this isolated little curve full of water. It's now a lake. It's called an oxbow lake. So just a reading check for yourself. How would you describe the gradient of a river that has meanders? So you can think about that for a second, pause the video, try to get an answer, and then move on when you're ready. Right, so how would you describe the gradient of a river that has meanders? A river that has meanders probably has a low gradient. Remember, if it had a high gradient, the water would be moving really fast, and you wouldn't have any kind of moving around. It would just push through things. So, braided streams. A braided stream is a stream or river that is composed of multiple channels that divide and rejoin around sediment bars. A braided stream, they're usually a direct result of large sediment load, particularly when a high percentage of the load is composed of coarse sand and gravel, so it's just an enormous bed load. Although braided streams look very different from meandering streams, they can cause just as much erosion. You can almost think of it as like a whole bunch of meandering streams in the same space. So here is an illustration of a tributary river system and drainage basin. There should be plenty more illustrations in the textbook and online, but for now, that's chapter 15, section 2.